This material that we are beginning today, okay, logic and truth tables, this is not on tomorrow's quiz. It's just the previous assignment and lesson, intro to sets. Okay, that's coming up tomorrow. All right, so we're going to be talking about basically your if-then statements. Okay, and these are made of what we call propositions. Hello. Are y'all done, ladies? Okay, let's put it in the tray for me. Thank you. Okay, so starting off, well, what is a proposition? It's a statement that is either true or false, never a question. It's also never a command. So as long as it's a statement, okay, whether it's true or false has absolutely no bearing on that. Okay, so the first thing we're going to do is make sure we can tell the difference between what a preposition is and what a preposition is not. Okay, so identify which of the following are prepositions. Circle one. Okay, so A, the preposition today is Friday. Proposition or not a proposition? It's a proposition. It's a statement. It's not true, but that doesn't matter. Okay, it could be true, it could be false, as long as it's a statement. Never a question, never a command. All right, what about 3 plus 5 equals 8? Okay, that's a proposition, and it happens to be true. Okay, what about take the quiz? Okay, that's like a command. That's take the quiz. So that is not a proposition. Okay. What about 7 is less than 11? That's a proposition. Happens to be true. Okay. What about put your hat on? Okay, that is not a proposition.
What would
Okay.
be an example of a mathematical command? Or
A mathematical command?
sorry, a mathematical, not a problem.
Oh,
Words are hard.
okay. Maybe something like if you're just saying like to perform a particular operation, like multiply 2 and 8.
Okay.
Okay. It's a statement, but you're more telling somebody to do something. Or is the product of 2 and 8 16? Because that's a question. Okay. It's just a flat statement. Could be true, could be false, and that does not matter. Okay. All right. A proposition is usually represented by the letters P, Q, or R. The truthfulness or falsity of a proposition is called its truth value. I was actually really, really disappointed yesterday. I'm glad somebody asked why. Okay. Because otherwise, if it had been, like silent or really awkward, it wouldn't have been a good segue into this. But I went to the new Spirit Halloween store yesterday because I had an idea. I wanted to wear Vulcan ears today because we're talking about logic, and I wanted to get myself like a blue uniform that I could walk in and be like, peace and long life. And you guys would be live long and prosper. And I'd be like, yeah. But you're the only class that's doing it.
Would every other class
Well, I mean, I would take my ears off during the others, but I would still be wearing the shirt. But unfortunately, Spirit Halloween had nothing Star Trek. It is. It's like blasphemous. Yeah, but by the time I thought about it, it just wasn't enough time. So maybe one of these years I'll actually have that done. But anyways, I just thought I'd let you know I'm inside. I'm a little sad.
next time?
There you go. Yeah. Everything's all Star Wars nowadays because of Disney. I mean, Star Wars is great. Don't get me wrong. Star Trek's better. Okay. Probably some people out there who disagree with me. Okay. The negation of a proposition can be formed by inserting the word not or do not. Not or do not as appropriate. The notation for the negation of P, we have this little symbol that looks like a sideways L, but I want to go ahead and make sure you're aware other resources may not always use the same symbol. In fact, it could be very common that you see like the little tilde symbol representing not. So if you see that sideways L, typically what I'm going to go ahead and use, or that little tilde symbol, okay, well, you've seen that for similarity in previous mathematics courses, that can also represent not, the negation of a proposition. Okay, so state the negation of the following propositions. Okay, so if the proposition states that today is Saturday, well, I'm going to go ahead and say that today is not Saturday. That's the negation. Okay, so today is not Saturday. All right, all mammals respire. All mammals do not respire. All mammals do not respire. Okay. And then what about the glass is full? The glass is not full. Yeah, so it's really easy to verbalize the negation of a statement. Okay, that's not a problem. The glass is not full. Okay, personally, I always look at the glass as being half full because I like to try and be optimistic. But, Amy.
On P, could you say no mammals respire, or would that?
Actually, I think as long as the intent comes across, I would think it'd be fine.
Okay.
Okay. It's just in the beginning here, especially when we're looking at truth tables and we start to tie them into our Venn diagrams and intersection and union, there are specific words that we're going to want you to use in the beginning, but you can absolutely rephrase it, later on. That's fine.
Well, because I know that saying no mammals respire versus all mammals do not respire is saying two different things.
Yes. Okay.
Sorry.
Okay. So here's the truth table. So the first couple of columns are typically going to be your propositions. Well, here we only have the one proposition. So that tells you what we're doing in that column. And you'll notice we have a certain number of rows for a number of propositions that we have. Now, I know it's going to be kind of strange right now, but as we move on, you're going to see how we're going to determine the number of rows that a truth table has. Okay, typically your truth table is probably going to have 4 rows because we're going to have 2 propositions that we're going to be dealing with. Okay, and it's coming up in this lesson, but I'll just go ahead and let you know. The number of propositions you have, okay, you always take 2 and raise it to that number. 2 to the number of propositions, and that tells you how many rows. So for example, 2 propositions, 2 squared is 4. Let's say I were to have 3 propositions that they were talking about, P, Q, and R. How many rows would I need? 2 cubed, 8. So there would be 8 rows. So your table could get conceivably pretty large depending on the number of propositions you have. Okay. Now it says, note, the negation of P in logic corresponds with P prime, the complement in sets. So we would go ahead and shade everything out of here. Okay. Good. Erase this right here. That was for an example I did when we reviewed, so we'll come back to that one. Okay. Now, conjunction. A conjunction is formed when 2 propositions are connected by the word. You remember I mentioned this the other day? And. So conjunction is just another word for, starts with the I. Intersection. There we go. Intersection. Okay. So intersection and conjunction can be used interchangeably. In fact, the symbols we like to use, remember it was a capital upside down U, or it was a capital upside down V. There we go. All right, so here's my example. I've got 2 statements here, 2 propositions. London is the capital of England, and Houston is the capital of the United States. So I want to state the conjunction or the intersection of the 2. All right, well, all I'm going to do is hook these 2 sentences together with what word? And. Okay, so London is the capital of England. London is the capital of England. And Houston is the capital of the U.S. Okay. Remember, it does not matter if the statement is true or false. That's what the truth tables are going to help us determine. Okay, the validity or, like I said, the falsity of the statement. Okay, so here's the truth table for a conjunction. Okay, so really, especially in your formula book that you're going to receive when you take the paper exams, the good news is they do provide these tables for you. You just have to remember what they mean and the symbols that provide that. So when you see that capital upside down V, which is typically what they like to use for these tables here, you'll notice you only get a true when what? Okay, when they're both true. If one of them is false, it's a false statement, or if both of them are false, it is a false statement. Okay. So there's all the different behaviors you can have when dealing with a conjunction. All right, so that is the truth table for a conjunction. Any questions on this? Okay, they both have to be true at the same time. All right. Okay. So the and means that all parts of the conjunction must be true for the conjunction to be true, what we just did about that. Okay, this is equivalent to an intersection in sets. Now, if I go back over here, I'll go ahead and shade it in. It's not really necessary, but just to kind of link the idea. Okay. A conjunction is equivalent to an intersection when dealing with our sets. Okay. Now let's move on to disjunction. A disjunction is formed when propositions are joined by the word or. What am I talking about here? Starts with a U. The union. There we go. So the union. Okay, a capital U or a capital V. Okay. So let's try this one. Okay, given the same two sentences that we had a moment ago, propositions. London is the capital of England. What? Or Houston is the capital of the United States. Okay. Would everybody be okay if I just didn't write that again? Maybe I just put or? Or does anybody want me to write the whole thing out? You do? Okay. John Henry, I will. Yeah, it's okay. I'm already started. London is the capital of England. Or Houston is the capital, okay, of the U.S. Okay. So here's what we're going to be looking at here, okay? There's that capital V. This is telling me the union, the disjunction, okay? So here's the thing about this. The truth value of a disjunction is true when at least one of the propositions is true. So another way of saying this, the behavior depends on the validity of these original statements. It's one or the other or both. That's a really good way to think about it. Let me write this over here. One or the other or both. Okay. So what do you think the disjunction would be if both statements are true? Is it true or false? This will be true. Okay. One or the other or both. Okay. So what about if the first is true and the second is false? That would still be true. When we're talking about a union, it's still considered a true statement as long as one of them is true. Okay. So what about false true? True for the same reason. But what about false false? This is the only one that's false here. At least one has to be true in order to get a true result. So that's a false. Okay. All right, good. Now it says note P with a disjunction of Q in logic corresponds to P union Q, the union of sets. We were just talking about shading before we started here. So I'll just shade the whole thing right there. Okay, questions. How we doing? Oh, because that's the union. Remember, that's what the disjunction does. Okay, one or the other or both. Okay, remember, I described it as the marriage. Remember, we combined the two sets into one brand new set. Okay, all right. Now, here's where it gets interesting. The use of or in the disjunctions above is inclusive. That is, either one or the other can occur. For example, Sid shall go home if Rory is running late or if it's raining. This sentence means that if either Rory is running late or it's raining, Sid's going to go home. It doesn't matter which one turns out to be true, Sid's going to go home based on one of those. Does that make sense? One or the other or both. The or is inclusive because Sid will go home if both events occur or if only one event occurs. All right. Now, here's what we call exclusive. The exclusive or means either one or the other, but not both. Okay. So think about the example they're giving you right here. You'll go to Richmond by plane or by car. Is it physically possible to travel to Richmond, Virginia in both a car and a plane at the same time? It is?
Like a mistake.
Okay, I was here. Okay.
One leg in the car, or if you're pushing the car up with your hand first.
Okay, on the rare occasion that a person would be sitting in your vehicle while in the plane, maybe. But typically, for us normal folks who are going to sit back and coach, you're not going to be taking your automobile with you. There's not enough room for you in coach, let alone you in your car. All right, maybe in first class. Okay. But see, that's the point. Physically, it would be impossible to be in both the car and the plane at the same time. The exception excluded. Okay. So there is a difference here. When you're talking about inclusive, okay, the one symbol where both could be true, you simply have the capital V. That's inclusive. But if you see the symbol where you have V, but you have that little bar below it, which would probably indicate to you equality, that bar means exclusive, so both cannot be true at the same time. Okay. So, for example, here, true would actually give me a false when we're talking about the exclusive or. Okay. One or the other, but not both. Okay. So what do you think about true, false? That's true. What about false, true? That's true. What about false, false? That's a false. Remember, in this instance, at least one of them has to be true, but not both. Okay. Can anybody give me another example of a statement that's exclusive, with an exclusive or? Nobody can think of one? Okay. So I will do my math homework, or I will do my eco homework. Okay. Is it not? I guess it's not possible to do both at the same time. Yes. I guess technically you could.
I will do Monopoly, or I will keep my friends.
Yeah, that's pretty much all Monopoly is. It just starts fights. That's why Monopoly has pretty much been outlawed in my family, because they take it seriously. I mean, we're talking. This is where the table flips. It's like.
The last time we.
So who was the comedian who did the bit on Monopoly? Dane Cook.
I think it's.
If you ever. Or okay, but his little segment on Monopoly is dead on. Okay, so what would I shade here? One or the other, but not both. So remember, do you guys remember what this symbol means right here? And this goes back to the first lesson. We didn't see it a whole lot. It did start with a D. Difference. The backward slash meant difference. Okay. So in fact, would somebody like to come on up and show me where the shaded region should be for an exclusive or? This type of disjunction. Okay. Or does anybody want to show me what they have on their paper, and I can tell you if it's correct or not? Elizabeth's already shaking her head no. Okay. Joey, come show me what you did. Because you're correct. I wouldn't call you up if you weren't correct. Well, maybe I would. Okay. There you go. What was the one region he didn't shade in? Where they intersect. Where we're talking about the exclusive or, it can be one or the other, but not both. Okay, so very good, very good. How we doing?
Pretty good.
Well, let's say general math-wise. Meh. Okay. All right. Well, let's keep going. Let's see how far we can get. Let's see here. Additional examples. Given the following propositions, determine if their inclusive disjunction is true or false, and give a reason. All right. Well, whether you're dealing with the inclusive or the exclusive, as number 2 is, what's the key word here? Okay. I want to know what word is always associated with a disjunction, whether it's inclusive or exclusive. Or, there we go. Okay, so I can make a sentence that says 23 is a prime number, or what? Or the graph of y equals x squared is a parabola. The graph of y equals x squared is a parabola. Okay, so here's my sentence. 23 is a prime number, or the graph of y equals x squared is a parabola. Now remember the definition of inclusive. It's one or the other or both. Okay, so is 23 a prime number? Yes. Is the graph of y equals x squared a parabola? Yes. Can they both be true at the same time? Yeah. Okay, so I would say that statement is true. Okay, because they both can be true at the same time. Okay, do you want to try number 2 on your own? Okay, Elizabeth says yes. All right, let's do it. Okay, I'm sorry, here's where you said yes. Oh, if only you said something before I asked. Okay, let's try it on our own. Okay, so try to write a sentence. Remember, the key word is still or, but now don't say it out loud. Now you're basing it off the exclusive disjunction. Okay. Okay, remember, think about what it means when we define exclusive. Writing the sentence should be pretty easy. Okay. Microphone. 202. So anybody want to tell me what they wrote for their sentence? There you go. 42 is a multiple of 4 or 3. And that's good. I like the way you kind of shorten the whole sentence. How many people put 42 is a multiple of 4 or a multiple of 3? Both would have been acceptable. That's perfectly fine. Okay. Here's my question. Is it true or false? Now, I'm hearing more trues, but I did hear one false. Who said false? Now, what does exclusive mean?
It means it can be one.
Okay. In fact, think about the behavior we have over here in the truth table. Okay. One or the other, but not both. So if they're both true, that's when we have a false. We only get a true statement if one of them is true. Okay, so if I come back over here, okay, is 42 a multiple of 4? No, that is false. That is false. Okay. Is 42 a multiple of 3? That's true. So as long as it is, even though it contains one part that's false, this statement is still true. One or the other, but not both, gives you a true statement. Okay. Is everybody okay with that? All right. Well, I'll tell you what, since I've got 204, this will be the last thing we go ahead and talk about, and then we'll just pick up here tomorrow. I already mentioned this. If you have n propositions, you'll have 2 to the n lines in your truth table. So 2 propositions will give you 4, 3 propositions, 2 cubed will give you 8, just like I mentioned at the beginning when I first started bringing up truth tables. But this next example, let's at least go ahead and get all my sets created, and then we'll have that ready for tomorrow. It says, let U be the set of all counting numbers from 0 to 50. So 0, 1, 2, okay, 0, 1, 2. And I'm definitely not going to list all of these all the way to 50, just the counting numbers.
I suppose it would be helpful to me. Would you do it?
If you want me to. If you want me to list all 50, I will. That's the kind of teacher I am.
Well, thank you for that. But
Do you actually really want me to do that?
no, I was.
I'll trust
Okay.
you. I'll trust you. I'll take your word.
appreciate that, Joe. Okay. All right. And see, that means a lot, man, because Joey's been on his game today. Joey's doing awesome. Okay. All right. X is an odd number between 0 and 20. So what would be the first value? An odd number between 0 and 20. Well, 17 is 1, but what's the first number? There we go. I like people just saying random numbers. 17. Okay, that's true. Okay, well, let's go 1, 3, 5, 7, 9. Then we have 15, 17, 19, and we can't go any further. Oh my God. Well, we got 11, 13, 15. You know what? I got stuck on 17. Give me a break. All my mental energy was focused on 17. 17! Okay. All right. X is a factor of 45. Oh, okay. So definitely 1 times what?
45.
Oh, I'm sorry. I thought you were talking to me. So 1 and 45. Not divisible by 2. What about 3? 3 and 15. 4, 5, and 9. And I think that's it, right?
That is it.
Okay. So 1, 3, 5, 9, 15. And 45. There we go. So I got my 3 sets ready. So we're going to use these to answer some questions, create some truth tables, and then shade them in accordingly. Okay. So there we go. We'll go ahead and stop there. We will pick this up again tomorrow. We should be able to start with our focus activities again tomorrow. I should be able to pass back your chi-squared and answer any questions on it. Okay, but if you have your outline or the assignment that you didn't turn in, please do so as soon as you can.